Hey everyone, welcome to another tutorial. In this tutorial, we'll be covering Dueling Deep Q Networks for reinforcement learning. This reinforcement learning architecture is an improvement on our previous tutorial, Double Deep Q Network architecture. So before reading this tutorial or listening on YouTube, I recommend you to read or watch my previous tutorials. In this tutorial, I'll introduce the Dueling Double Deep Q Network architecture and its advantages and how to build one in Keras. We'll be running the code on its same OpenAI Gym CartPole environment so that everyone could train and test that quickly and easily. In future tutorials, I'll be testing this code on environments which are more complicated games which will need convolutional neural networks. For an introduction to reinforcement learning, you can check my previous tutorials on my page or my YouTube channel. So, to get deeper understanding of Dueling network, we should recap some point from Double Q learning. As discussed in previous tutorial, vanilla Deep Q learning has some problems. These problems can be boiled down to two main issues: the bias problem. This is when vanilla Deep Q networks tend to overestimate rewards in noisy environments, leading to non-optimal training outcomes. And the moving target problem, which means that the same network is responsible for both the choosing of actions and evaluation of actions. This leads to training instability. Dueling Deep Q network architecture trades on the idea that the evaluation of the Q function implicitly calculates two quantities: the value of being in state S and the advantage of taking action A in state S. These values, along with the Q function Q, are very important to understand. I will not do this on video tutorial, but you can do deep dive of these concepts in my text version tutorial. Well, it's quite complicated to explain this, and yeah, you can just read it on my page. So, consider, I have an image here. Consider following image taken from the original Dueling Deep Q Network paper. So, showing the value and advantage components of the Q value in the entire game. This is an enduro game. The goal of the agent is to pass as many cars as possible. Crashing into a car slows the agent's cars down and therefore reduces the number of cars which will be overtaken. In the image, it can be observed that the value stream considers the road ahead and the score. However, the advantage stream does not pay attention to anything much when there are no cars visible. It only begins to register when there are cars close by and action is required to avoid them. This is a good outcome, as when no cars are in view, the network should not be trying to determine which action to take, as this is a waste of training resource. This is a nice example of showing the benefit of splitting value and pattern function. If the machine learning engineer already knows what is important to separate value and advantage values, why not build them into the architecture of the network and save the learning algorithm the hassle? That is essentially what the Dueling Q network architecture does. Consider the following image showing the original Dueling Deep Q network architecture. First, notice that the first part of the architecture is common, with convolutional neural network input filters and a common flattened layer. We will use this architecture later when we'll do something more serious than CartPole. After the flattened layer, the network divides to two separate densely connected layers. The first densely connected layer produces a single output corresponding to Vs. The second densely connected layer produces n outputs, where n is the number of available actions, and each of these outputs is the expression of the advantage function. These values and advantage functions are the aggregated in the aggregation layer to produce Q-values estimations for each possible action in the state S. These Q-values can then be trained to approach the target Q-values generated via the double Q mechanism. So as usual, we create a common network consisting of introductory layer which act to process state inputs. Then two separate streams are created using densely connected layers which learn the values and advantage estimates respectively. These are then combined in a special aggregation layer which calculates Q-values. Once the network architecture is specified, the training process proceeds in the same fashion as double Q learning. The agent actions can be selected either directly from the output of the advantage function or from the output Q values. Because the Q values differ from the advantage values only by the addition of the VS value and the argmax selection, the best action will be the same regardless of whether it is extracted from advantage or the Q value of the network. So to begin with, I'll start with my previous tutorial. I'll copy the code simply. I'll rename it to double, and here we'll make a double Q network. So this means that in this part we'll be done. We finished with theory part, and we'll start with practical part. And in this part we will build the Dueling Deep Q Network architecture. However, the code will be written so that double Q and Dueling Q network will be able to construct with a simple change of Boolean identifier, so that we could easily compare results, while Dueling Q was originally designed for processing images. With its multiple convolutional networks layers at the beginning in the model, in this example we will be replacing with CNN layers with simple dense connected layers. So our results do not show any improvement. Because training reinforcement learning agent using images only, for example Atari environment, takes a long time, in this post or tutorial only a simple environment is used for training the model. In future tutorials I will learn how to train, I will show you how to train reinforcement model on games like Atari, where you need some kind of pixel input or so on. So let's begin with creating a Keras model where we could easily switch between dueling or not dueling model. So I'll begin here with my inputs. So what I'll need is additional lambda layer and add layer. Then I will need to import something from Keras, import backend as Keras, and here we would like to choose if we use a dueling or we are not, like that. And simply what we change here is we add a gap here, and here I'll write if dueling, and here we'll do something like state value. So we'll do here equal dense equal to 1, and here will be kernel initializer equal to h uniform, and at the end it will be again x, and then I'll write a state value again equal to lambda layer of function lambda s of Keras expand dims, and here will be on s, and here something like this, and we go to the end of -1, the end. So then I'll write an output shape output shape will be equal to, let's add one more, so it will be equal to action space, and that's it. At the end I just need to write a state value. So that means that for this layer input is this layer output. So now what I need is write a few more layers. So now we wrote our state value, now we need to write an advantage. So action advantage will be equal, also very similar, it will be dense layer, but now here it will be my action space. Kernel initializer will be the same, h uniform, and input will be x. And now we can probably copy this and we'll change few lines to this. So action advantage will be my lambda layer, same as before. Before it was s, now we'll use something like a, and here I'll write that something like that minus k-mean of a from 0, something like that, and that. I hope this is, I wrote everything right. And now keep dims equal to true. Now output shape is action space, the same, and yeah, action advantage will be the input for this layer. So lambda a double dot a minus k mean a. Yeah, it looks fine. So now what we need is our x, and here we'll use add 2 layers, and this will be our state value and action space, action advantage I mean, that and like that. So this is what we do when we try on dueling mode. So I'll try to explain this shortly now, for short. So if the network is specified to be dueling, then the value and advantage streams are created. Then a final single dense layer is created to output the single state value estimation Vs for the given state. However, keeping with the dueling terminology, the last dense layer associated with the action advantage stream is simply another standard dense layer of size equal to action space. So each of these outputs will learn to estimate the advantage of all the actions in the given state A as from A. So these layers specify the advantage and value streams respectively. Now the aggregation layer is created. So this aggregation layer is created by using 2 Keras layers, lambda layer and add layer. The lambda layer allows us to specify some user-defined operations to perform on the inputs to the layer. So finally, we need a simple Keras addition layer here at the end to add this mean normalized advantage functions to the value estimation. So it's quite simple. Now, while we wrote this, we can add here a dueling that are, but we know that what we are doing, that is our dueling model. So now we need to add something like it was here. So definition, self dueling will be equal to true, and then action size, yeah, we here need to add dwelling will be equal to self.dwelling. I'll copy this, that our model is identical, nothing much, nothing a lot. So actually this is the main steps we needed to do to implement this dwelling mode. Now I go to my, everything stays the same as before. It's a replay method, everything is the same. Load plot model. Here we need to do some changes, and here I'll need to add a dwelling equal to something new, and here I can write everything in one line to save some space like that. And okay, I will add one more here. It will be if self-dwelling. Dwelling will be something like dwelling, I think. Dwelling, and here we just add dwelling to the name. I wrote dwelling in large or more small. Yeah, it's in small. So everything is fine. What else might be wrong here? So that model fit everything here. Let's go to my run model, and I think here we can save this model to CartPole Dueling Deep Q Network, but anyway, don't need this. I'm not saving for my model for now while I'm testing different strategies. I'm just testing them on their performance while training. So I think that's it. If I would run right now this model, we also don't need this, but well, doesn't matter for now. It might stay here. And if I'll run this, the model now, it would be Dueling Deep Q Network with dwelling. So I can try to see if everything is fine here, if I don't have any errors. Of course I have. Expand dimensions somewhere here, and yeah, expand dims, it should be like this, and then go 0 and -1. Okay, let's build again, and it seems that it's working, and it's right now in training, and shortly you should see that the average score keeps increasing now. And right now I'll stop the video. I will train all 3 models and I'll come back to you. So we'll see. So now I've finished training process, and we can compare the training progress of the agents in the CartPole environment under the Dueling Deep Q Network, Dueling Deep Q Network, and Dueling Deep Q Network architectures. Can now be observed in images. I will show you now, but at first let me, as you can see, they are all different names, as you can see. So we'll begin with simple Deep Q network. My image went to another screen. So as you can see, it performs better than it was doing without dwelling. You can see without dwelling we didn't have so much spikes, which reached 4,000. So we can say that probably yes, dwelling is working. Next example, sorry, not this one. This is a simple network, not dwelling. It's just a Dueling Deep Q network. As we can say, it's the same from our previous tutorial. I simply, as you can see, added a moving average to show our last 50 steps here in our code, in our graph. And as you can see, we can compare our, this is not dwelling or dwelling. Yeah, it is Dueling and Double, so Double Dueling Deep Q Network from this name. And as you can see, it performed the best, and even it reached about, I'm not sure, 1000, almost 1000 in 50 previous average scores, or 25, I don't remember what tried it. But anyway, we can say that yes, Double Deep Q Network with Dueling for now is the best what we can do, and it's quite hard to say if it was big improvement or not a big improvement with Dueling, but I can see and I can say that yes, there was improvement, and yes, it's worth to do this. And as can be observed, there is slightly higher performance of the Double Q network with respect to the Dueling Q network. However, the performance difference is fairly marginal and might be within the variation arising from the random weight initialization of the networks. There is also the issue of Dueling Q network being slightly more complicated due to the additional value stream. As such, on fairly simple environment like the CartPole environment, the benefits of Dueling Q over Double Q might not be realized. However, in more complex environment like Atari environments, it's likely that Dueling Q architecture will be superior to Double Q, and this is what the original Dueling Q paper has shown for us. If you want, you can check this. So in future tutorials, we will demonstrate the Dueling Deep Q network architecture in Atari or other more complex environments. In the next tutorial, we'll try to implement prioritized experience replay method, and we'll see what we can get with it. And yeah, with that prioritized experience replay method, our score should improve significantly. It's quite hard for me to say how hard it might improve, but I think that it should be noticeable. And of course, I'm thinking about future tutorial, what I should do in convolutional neural networks, how that I should prepare a tutorial where we could use some kind of pixels for our Q model to train, but I will think about that in future tutorial. So that's it. Okay, for now, this is the end of this tutorial. I hope this tutorial was useful for you, and of course, share my video, like it, and subscribe my channel, and see ya in more future great tutorials. Thank you for watching. Goodbye.